Okay, so the problem says a block of mass m1 is equal to 3.7 kg, which is this one, 3.7 kg, on a frictionless plane inclined at an angle 30 degrees, connected by a cord over a massless frictionless pulley to a second block of mass m2 is equal to 2.3 kg. So the first mass m1 is on a frictionless surface that is inclined at an angle of 30 degree, and this is connected to another mass through a pulley, which is the second mass is 2.3 kg. So we have to find what are the magnitude of acceleration of each block and the tension in the block, in the cord, basically I would say be tension in the cord. So yeah, so yeah, so the tension, well, we have to find the tension in the cord, which so basically this one, because of this mass, the weight force, the component of weight force in this direction will be m1 sine m1 times g sine theta. Theta here is 30 degree because this is inclined over a plane of 30 degree. If it were 90 degree, then sine 90 degree would be 1, and that would be mg. So weights component in this direction, downwards direction, is m1g sine theta. So the acceleration, if we say the acceleration is acceleration is a, let's say, and we can see that this is 2.3, so this one's weight is m2g, and the second one's weight is m1 g sine 30 degree. So this one is 2.3 into 9.8, which gives us 22.54 Newton, and 3.7 here times 9.8 times sine 30 degree, which is 0.5, gives us 18.13. So of course 13 Newton. So of course this force is greater than this force. So the acceleration will be in this direction, So we can write the equation as m1 plus m2 times a will be equal to m2g minus m1g sine theta. So the difference will be m1 times m2 a, because that will be the acceleration. Both of the blocks will have the same acceleration, and that times mass will be the force that is acting on that direction. So we get a to be, this one here was 22.54, we already calculated, minus 18.13, and here it is 2.3 plus 3.7, so we get acceleration to be 0.735 meter per second square, and the direction is of course downwards, not upwards. So if we think in terms of mass too, we can say it is downwards, not upwards, so down we can say. So that's the direction, and the tension in the cord, that's what we need to find. So the tension will be in this direction, T, and tension will be T minus m1g sine theta is equal to m1a. That will be the equation for tension, because this tension force is acting in this direction and m1g sine theta is acting in that direction. Tension in the cord is acting in that direction, and m1g sine theta is working in this direction, and the acceleration, these two subtracted value will be the acceleration, which is in that direction. So that's what we have written here. Tension which is acting towards right, we can say. If we maybe I can draw the diagram here again. So tension is this way, and this one is this way, and the subtracted value is the mass times acceleration. So tension will be m1 here a plus g sine theta. That will be the tension. So this one is 3.7 and A is 0.735 and this one is 9.8 times sine 30 degrees 0.5. So let's say what we get. Let's see what we get. So we get 20.8 Newton. So that is the value of the tension in the cord.